In this video, we're going to elaborate a little bit more on the ideas of domain and range, which we talked about in one of the first lessons of this unit. So I've listed the definitions here on this slide. The domain of a function is again the set of all the possible x values that work within the function. So those are the values that work as inputs for the function. The range of a function is then on the other end of the process. It's the set of all possible y values that can be output from the function. So it's important to make sure that you are able to appreciate the distinction between the two. The domain are all your working x values, the range are all your working y values. So the easiest way to determine domain and range is actually to look at some functions that we know fairly well. And so I have f of x here is equal to x plus 3. I've got g of x is equal to a quadratic 2 times x minus 1 squared plus 4. And we're going to look at those to figure out domain and range, and then extend those ideas to some more complicated functions. Now x plus 3 is just a line, and so you're fairly familiar with what this looks like. In fact, if I was to draw a very crude sketch here, x plus 3 looks something like this. And so you can kind of tell from the graph of a line that any x value would function in this equation. In fact, looking at the equation, there's no number I could pick to substitute in that wouldn't give me a y value back. And by extension, if I can substitute in any x value possible, it means I can get any y value possible as a result. So the domain and range are actually going to be all the real numbers for this. And so this is how we will write it out. First, I'll write a d for my domain, and I'll write it that x such that is what the vertical line means, such that x is an element of the real numbers. So again, those new symbols here, the vertical bar means such that, and the fancy looking E symbol means is an element of. And basically what I'm writing there is that any x value works in this function provided that x comes from the real numbers. And so my range I can write out very much the same way. My range is such that y is chosen so that y is an element of the real numbers. Now if I look at a quadratic, it's a very similar idea. A quadratic in general will extend for all x values, but there is always a cutoff for the y values. If I look here, I have a minimum, and so I don't have any y values below whatever the y value of my vertex is. So that's going to be important to note because that's going to restrict my range. My domain will still be all real numbers, same as it was for the line, but my range is dictated by wherever my maximum or minimum value is. So here, in this particular quadratic, the y value of my vertex is 4. And because it opens up with a positive a value, I know that this is going to have all y values as long as or such that y is greater than or equal to 4. So that would be my range for that quadratic function. Here I have two new functions. H of x is the square root of x minus 3, and j of x is 2 over 3 plus x. Now I've introduced these because these are actually meant to highlight where you will see restrictions in the domain. So the range you'll always just kind of have to think about when you write out what the range is. The domain you can actually tell fairly easily because you basically look at the two scenarios that could break a function. So the two things that we could do that would be problematic to using a function would be square rooting a negative or dividing by 0. So in this function h of x, I can see I'm square rooting x minus 3. So it stands to reason that the only x values I cannot include in my domain are going to be the ones that would result in me square rooting a negative. So the easiest way to determine that is look at what's under the square root, set it equal to 0, and that'll tell you your cutoff is x equals 3. So as soon as I use x equals 3, I'm square rooting 0, which is fine. Square root of 0 is 0, so there's no problem there. But if I go any smaller than 3, even 2.9, now all of a sudden I have a negative under the square root, and that's problematic. So this tells me that my domain has to be set so that x is chosen such that x is either greater than or equal to 3. If I pick anything less than 3, this function is not going to work. Now for my range, I can't tell it necessarily by looking at the equation and crunching some numbers. But if we keep in mind I'm taking the square root of something, we should remember that if I'm taking the square root of any number, my result is going to be a positive number. So my range here is limited by that fact. I can say my range is y such that y is always going to be greater than or equal to 0. Now if I move on to the function below, j of x, which is equal to 2 over 3 plus x, here the issue with the domain is not that I would be square rooting a negative. Here there's the issue of dividing by 0. So I have to look at my denominator and ask myself what x values, if any, are going to make that denominator 0. And I think people can see fairly quickly, without me even pulling this equation out and looking at it, that if I substitute in x is equal to negative 3, I am dividing by 0. So that's the one value I have to restrict out of my domain. Anything else would be fine. Really small values are fine, really big values are fine. Everything else is fair game. The only thing I can't use is a negative 3. So I'm going to write my domain as x such that x cannot equal negative 3, and that solves my problem. Now my domain is set up to eliminate that value from the possibilities. This should look familiar to you because what we've actually just done is the same as when we were stating restrictions with rational expressions. We were looking for the values that would be substituted in that would result in division by 0 and eliminating them from being used. Now the range for this particular function might be, again, a little bit tougher to spot, but the key thing is I have to look at what this function can never be equal to. So if my x values are ever really small, the y value from this function is going to be really close to 2/3. If it's a really small negative or positive, that's going to be the case. If it becomes a really big negative, I'm going to have a very small negative number. If x is a really big positive, I'm going to have a really small positive number. And I can fit anything in between the really small positives, really small negatives, all the way up to fairly large positives and negatives. The one thing that I can never get from this function, though, is 0. If I set this equal to 0 right now, 2 over 3 plus x equals 0, and I try to find an x value that works for, first thing I do is I multiply both sides by 3 plus x, which gets rid of it on the left, and because I'm multiplying by 0 on the right, I end up with this, which is obviously mathematically invalid. And so this tells me that there is actually no x value that will make this function equal to 0. So that's the only value that's going to be restricted from my range. It's y such that y cannot be equal to 0. So in this next function, I kind of combined the last two to make this function r of x. It's 1 over root x. And so I have the problem that I can't square root by a negative, and I cannot divide by 0. So when I go to restrict my domain, I have to consider both of those properties at the same time. So I know here that x has to be greater than 0, but it also can't be equal to 0. So I'm just going to write x is greater than 0. And my range here is y such that y, again, cannot ever equal 0, but it's actually a little bit more than that, if you think about it. I could look at it this way and say, oh yeah, 1 over root x, set it equal to 0. I get that same problem where I have 1 equals 0, bad things have happened. And yet, there's another restriction on the range, because root x will only ever give me a positive number. So I've got a positive 1 divided by some other number that's positive. That means my y value will only ever be a positive number. So it's not enough to just say that y can't equal 0, which would have been the range for only one aspect of the function. I have to say actually that y is always greater than 0. It will never be negative, and it will never be equal to 0. So by looking at functions and thinking about the operations that would break them, for lack of a better word, you can actually figure out the domain of the function pretty quickly. The range takes a little bit more puzzling, but if you think about it logically, think about not specific numbers, but general numbers that you can get as your results. That'll help you narrow down the range for the different functions. Now, you're going to be looking at questions that give you equations that you have to do this without a calculator and some that you have to do with a calculator. But either way, you should be able to analyze these fully now to state the domain and range.